Good day, my name is Donovan Bana.
My name is Fawaz Dosran.
I'm Alam Sulal.
And I'm Zahir Abbasali.
And we are Apex Engineering.
Our team has been hired to design a citrus juicer for mass production and distribution to a wholesale market as a household appliance.
Hey Adam, what you working on there, man?
I'm working on, bro, just doing some research to make sure we design operates efficiently and as I said, we give into all the users. As a part of the group, some of my qualities are bringing us good teamwork skills and are very adaptable. Hey Fawaz, what going on, bro?
Oh, I'm just working on the CAD drawings based on the concepts that we came up with in final design.
Oh, cool,
as you can see here, based on the sketches that we have. Furthermore, I also bring to the team good team building skills, communication skills, and assistance with research.
As if you were doing there,
Bro, I'm just working on a new concept here for our fruit juicer, which in fact for the project that we are working on currently, I'm in charge of concept design and write-up. I also bring to the table very good organizational skills, analytical skills, and leadership skills. Donovan, what's going on there, bro?
Well, as you can see, we have no games going on in this area here. This is serious business. Right now I'm working on the hand calculations for our design to ensure that we have a good level of functionality and efficiency. Some of the qualities I bring to this table are analytical skills, adaptability, and problem-solving skills.
Nice.
Citrus fruits are quite popular due to their distinct flavor that is desirable in many forms of culinary practices and for their high vitamin C content. They also contain phytochemicals which are antioxidants. These include anti-oxidative, anti-inflammatory, anti-cancer, antimicrobial, and anti-allergy effects, as well as providing cardiovascular protection, neuroprotective effects, and HEPA protective effects. Methods of citrus fruit juice extraction vary based on the desired output. Therefore, the extraction process must be able to maximize yield and allow for quick and easy removal of waste. Our team has been hired by a large engineering company to design a citrus juicer for mass production and distribution to a wholesale market as a household appliance. Citrus fruits are very popular among the general public due to the nutritional benefits. Therefore, companies are constantly advancing and refining devices for citrus juice extraction. Our design must incorporate a balance of these factors in order to infiltrate and dominate the market. The project aim is to follow through the design process of conceptualizing a household citrus juicer for mass production and distribution. Our little review included a study conducted by Preventative Nutrition and Food Science, which investigated the effects of blending and juicing on the phytochemicals of fruit juices. The study indicated that fruits have a high concentration of phytochemicals, and previous studies suggest that plant phytochemicals have anti-inflammatory, anti-carcinogenic, and antimicrobial properties. Another study, entitled Citrus Juice Extraction Systems, investigated how different methods of extraction impacted upon extraction yield. The first method used two rotating cylinders to squeeze the juice out of the fruit, while the second method pressed a strainer against the fruit. Results indicated that the second method had a higher yield.
Another study showed that fruit residues are rich in bioactive compounds and provide advantageous dietary fiber and polyphenols. Furthermore, they can provide us with protection against diseases caused by oxidative stresses. Therefore, the processing of these residues have numerous health benefits along with the added benefit of waste management. Patent review. As seen above, it is an end view of this citrus juicer. This citrus juicer shown above comprises of a conical-shaped juicing head and a bowl-shaped collection container. The conical head is fixed to the container and held in place by a bolt running through it onto the container. The head contains grooves which allow for the easier extraction of juice, and the top of the head is blunted, which ensures that the head will not pierce the fruit and damage it. However, there are some flaws associated with this design, as it may result in a tough cleaning process and impurities in the juice. Our second pattern here shows a design which features a motor-driven cone which is fully surrounded on all sides by a strainer which has the necessary passageway for juice to flow through it while preventing unwanted byproducts. The juice is collected in a bowl under the strainer, as well as in the area between the cone and the strainer is configured as an annular gap, which is able to increase or decrease by the simple adjustment of the device. This configuration enables the pulp content of the juice to be predetermined, which is definitely an advantage. Our third pattern shows a citrus fruit juicer that is fit for a multitude of functions through the use of various attachments, generally making use of the mechanical construction of this intricate device. It can be easily switched to a potato shredder or even an oyster splitting device. Some of the featured attachments that can be seen in the drawing are a mobile anvil, a transverse locking pin, and an L-shaped mounting hook which is secured to the end of the collar. Our fourth and final pattern illustrates a modified food processor that can be turned into a fruit juicer. The machine is powered by an electric motor which turns a shaft that drives the juicing head. When a fruit is placed on the head, juice is extracted which then travels through perforations in the supporting member which forms a collection container. This removes seeds and pulp from the juice. Design conditions.
Now we will be looking at some user requirements. For the given application, it is desirable that the citrus fruit juicer has the following properties in order to be suitable as a household appliance. Number 1. Safety. Given that there will be children in this environment, this device must be safe and have no exposed electrical parts or sharp blades. Secondly, it should be user-friendly, with a fairly simple design, with a clear understanding of operation. Another point is cost effectiveness. This device must be affordable to encompass a large bracket of the population. The device must also be efficient and give a high yield with minimal wastage. Another factor is stability, and we know with mechanical devices, vibration will always come into play. So therefore, vibration must be minimized in order to avoid toppling. Another point is durability. This device must be durable and have a reasonable lifespan to make it a worthwhile purchase for the customers. Finally, ease of maintenance. This device would be used frequently, therefore dismantling and cleaning process should be relatively simple. This brings us to the design specifications. In order to fulfill these client or user requirements, our team has outlined some design specifications. Firstly, an enclosed area for the juicing process to take place. Next, a mechanism to ensure that the user's hand is not in close or direct contact with the reamer or squeezing mechanism. An insulated housing for electrical components or a gearbox for gear systems so that there is no hazard of electrical shock or pinching. This fulfills the requirement of safety. There should be a glass enclosure to avoid corrosion by contact with citrus acid over a long period of time. Rubber stoppers on legs or the base of device for shock absorption. There should be implementation of quick release clips for a quick and easy disassembly. Also, the device should occupy a maximum space of 1.5 cubic feet, that is, having a length of 12 inches, a width of 12 inches, and a height of about 18 inches, so that it fits comfortably on a countertop. Finally, a classy, sleek appearance is desired for an aesthetic appeal. Now, considering key attributes. Some of these key attributes for our design are simplicity, efficiency, ease of use, durability, and safety, just to name a few.
Metrics.
After considering the key attributes for our design, we now consider the metrics, with 3 being most desirable 1 being the least desirable and 2 being a value in between. As you can see, we have assigned these values and applied them to our key attributes, and they are as follows.
Pairwise comparison chart.
Our team constructed this pairwise comparison chart in order to compare our key attributes and assign a relative weighting to them based on their importance. As you can see from this table, safety is our #1 priority in designing this fruit juicer. Following closely behind is efficiency, and behind that is stability. As you can see, the results from the table display the relative weightings.
Design methods.
First up in our design methods, it is the functional decomposition chart. As you can see here, this chart shows the various inputs and outputs at various times in the process. It shows from the fruit all the way to the extraction of the juice, with byproducts and waste products ejectioned at various points. Secondly, the means tree. From this diagram, you can see that the trapezium, the words inside the trapezium represents a function, and the words enclosed by the square represents means and methods of achieving this function. So for example, the whole aspect of citrus fruit juicing, there may be multiple ways to achieve this, such as juicing through crushing or juicing through a motorized function.
Morphological chart.
Next up, it's the morphological chart. This chart shows various options for achieving certain actions in the process of juicing. A demonstration of this is for our juicing process. The energy source required we have for option 1 is electrical. Electrical may be the most suitable for this application, and this choice of selection goes forward in terms of most suitable for option 1.
Concept design.
Concept 1 is shown on the right. Concept 1 is a device which stands on 4 legs, each leg containing a rubber stopper that combats the effect of vibration. The motor turns a pulley system that is attached via a belt drive. This in turn causes the rotation of the reamer. The reamer is turned at a constant speed. Then, the fruits are cut in half and placed onto the spring-loaded clamps. There is a pair of spring-loaded clamps attached to a wheel, which is rotated via a handle. The handle is pushed forward onto the reamer, which juices the fruit. The juice then flows through the filter and out through the spout. Concept number 2 is a crusher as shown on the right. Concept 2 is a cylindrical mechanism that stands on 3 legs, each leg with a rubber stopper. The system is enclosed by a plastic cover which prevents the juice from leaking out. The system functions via a gearing mechanism enclosed in a gearbox. The gearbox is hand cranked, which moves the moving rack upwards and downwards onto the base plate. The fruits are placed on the base plate and the crank is turned. This causes the moving rack to come downwards, crushing the fruit. The juice then flows through the filter onto the drainage system and is collected for dispensing. Concept number 3 is a juicer as shown to the right. Concept number 3 is a cylindrically shaped device which stands on 4 legs, each leg having a rubber stopper. The principle of operation of this device is a half-cut orange is placed onto the spring-loaded clamps located on the cover. As the cover is compressed with the body, it depresses 2 pressure plate switches, which turns the motor on. As the motor is turned on, the reamer begins to spin. This causes the fruit to be juiced. The juice of the fruit is then flowed through the filter onto the container, which can be collected via the spout.
Key attributes concept rating.
The key attributes of each concept was rated on a scale of 1 to 3, 3 being the most desirable and 1 being the least desirable. It was seen that from this table that concept 3 had the best ratings out of all.
Selection matrix.
Based on the selection matrix shown, it was seen that the highest score was obtained by concept 3. This means that it should be chosen since it has the best scores out of all the key attributes.
Final concept.
The final concept was chosen to be concept number 3. The concept was not further modified due to the complexity of the device. The chosen concept was both mechanical and electrical, which operates by pressing the fruit onto the reamer by the cover. This increases the ease of use of the device. The device is operated by cutting the fruit in half, placing them onto the spring-loaded clamp, which grips the fruit so the user's hand is not in direct contact with the fruit or the reamer. As the device is compressed, the pressure plates on both sides of the device cause the motor to turn, which turns the reamer. When the reamer is turned, the fruit is juiced, which flows through the drainage system and can be topped off into a glass or a jug. Here shows a labeled orthographic view to the left of the slide and an isometric view to the right.
And finally, these are our references.